All right, what's going on, guys? What's up, everybody? And welcome back to our cyber defense path. Now, I've been putting this off a little bit because after this box, the next one's not available yet. So I tried to wait and it just was taking forever. So we're probably gonna have to skip some boxes, and that's fine. So let's get right into it. So this one is Sysmon. If you guys have never used Sysmon, it's made by Microsoft. We covered Event Viewer earlier, and this is kind of an extension of it, if you will, and I'll show you what I mean. So you can see here that the key here is the seam. So Sysmon is a way to import logs. Now you can use it on your machine, but it stays persistent, meaning when the machine goes off, when it turns back on, it starts back up, and that's key to it because obviously we don't want an adversary to just be able to restart the box and then boom, we're out of logs. But what Sysmon does is it allows you to really pick what you're monitoring. So when I say that is, you can see here, like this is a configuration file for Sysmon. So you can see what they're saying here is exclude this condition. Service host, app model, cam service, okay. So they're saying this is something we expect to see, so it's something we want to exclude from our logs, so don't log that, okay. But then, on the other hand, you can include stuff, and that's where you can actually say, okay, show me this, and the big thing is you can import these logs specifically to Seams, and you can get really nitty gritty with it. And then the Seams will take thousands of machines, right, and import all those logs and allow you to search them and find what you need and things like that. So while I do think this is extremely important to know how to do if you're looking for endpoint incident response, Seams also will provide this in a much better format, but you will have to configure that. So it's important that you know how to do this. So you can read all this stuff. You guys know how my tutorials go. I'm not going to read you what's on the page because you will be doing the box, so you can read that stuff. But I will cover what's going on. So network connection. So you can see here another rule they're putting in. They're saying include, so show in our logs, an nmap.exe. So if they see the nmap.exe running, and you can see the name, alert, metasploit, and condition is on port 4444. So if there's an nmap.exe and there's a port 4444, give me an alert, right? Make sure that gets noted in my logs. Now, the reason that you would make these rules, because a lot of people always ask, well, why not just include everything, log everything? Well, the problem is you would have to store those logs, and if you have 10,000 employees, that's 10,000 machines that are storing hundreds of thousands of logs a day. You're looking at an insane amount of logs sitting somewhere that then if something does happen, you have to actually go through them. So too many logs is just as dangerous as not enough logs. So keep that in mind. Okay, so you can see here, they're showing you the event IDs too, which is important because the event IDs you'll be able to search for, but keep in mind that all this stuff is Googleable, meaning if you don't know what event ID for network connections is on Sysmon, you just Google it. And I'm a big advocate of don't memorize stuff you don't need to. If you can just Google it real fast, it's not worth memorizing, in my opinion. Now, some people memorize them because they use them enough, but that's different. Okay, so you can see here this one too. Anything loaded in the temp folder, we need to see that, that type of stuff. Yeah, so you can read this stuff, guys. This is just showing you the different events that are possible with Sysmon that it's going to log, DNS events, file create, stream hash, blah, blah, blah. So you can see it's kind of geared more towards security, obviously. So here, installing and preparing. So this walks you through how to install it. Here's the machine box that I'm using, and you can see here I'm RDP'd into it already. It's very slow, so I'm very excited about that. And then let's go ahead and get back into it. So cutting out the noise. So this is, again, what we were talking about before, where you can start cutting these logs down and bringing these logs to where it's a manageable scale. So now your Seams will do a lot of this for you once you have it configured correctly to import what logs you want. It will make it very easily accessible and searchable, but we're going to show you how to manually do it. So you can see here, filtering events with Event Viewer. We've used Event Viewer on this channel before. Here's what they're basically showing you is how you filter logs, right? You go to filter. We'll cover all this. We're going to show how to do this. All right, now you can filter with PowerShell. Now I'm going to show you guys how to do both of these. but I'm only going to show you one of each. And then from there, we're going to kind of get off of the PowerShell kick, only because the events that they're going to give us for examples are very, very small, and you don't need to use PowerShell to filter. Now, first one, how many event IDs are in C users, blah, blah, blah. That's on the practice machine. So we move it over, and you can see here in practice, if we go to practice, we go to LS, and you can see it is in filtering.evtx. Now, if we go up, you'll see that I actually ran this. Okay, I ran get win event path. Now, you can see they give us this get win event path to log. I put the path to the log, which the path to the log here is simply filtering.evtx. Then you can see system event ID 3. I got rid of all that. I didn't want any of that stuff. Why won't it go over? I don't know. Okay. So now I got rid of all that and just left in system event ID 3. I got rid of all the event data, destination port, all that stuff. And you notice I'm assigning it a variable. I'm assigning it answer. Now, you don't have to do it this way. There's other ways to do it. But I assigned it that way so that I could just go type in answer.count. And it tells me how many. And there you go, 73,591. And you can see there's our first answer, 73,591. Now, what is the UTC time created for the first network event? Now, here, I'm going to use Event Viewer. I'm not going to use PowerShell only because I want to show you guys both ways. So here's Event Viewer. This is we're on the wrong ones here, but let's see if we can go ahead and get rid of. Might be under saved logs, but we'll see. Nope. Okay. So we'll go up here. We'll exit this, and we'll just go to investigation, or excuse me, we'll go to filtering. We'll open it up, and it's asking us what is the time created of the first network event. Now, there's two things you need to know here. One, the time created, it goes by time, so at the bottom will be the first one. And remember, 3 is the network event ID, so this was the first one. Now, here's the other thing to keep in mind. This 135, that is 52. That is not the time that it happened. That is the time that it was logged. Here's the actual time that it happened. 2021, you can see, let's match up the times. 2021, 01, 06, 135, 50, 464. Correct answer. Now, one other thing. I do want to apologize for the clarity here. This is the RDP software. That's why it's a little blurry. It's not my recording. It's this. So just keep that in mind. All right. So if you go on Windows Event Viewer, we go down. We go to the first event based on time. We look for the event ID number 3, which is a network and connection. And we give them the time. Boom. Easy, easy day. So we exit that. Now, for a little bit here, I'm not going to go through them. I'm not going to open them up because I was opening them up and going through to before I started recording the video. And I realized they're giving you the exact examples. They're giving you screenshots. So there's no point in me pulling them up to show you. But all right. So hunting Metasploit. So here is the difference, guys. This is the whole difference between script kiddies and actual hackers. Hackers use Metasploit. Script kiddies use Metasploit. A lot of people say, well, a hacker doesn't use Metasploit. Well, that's just not true. A lot of hackers use Metasploit. Now, the key is a hacker knows how to hide his tracks. Script kiddies don't. Okay? This is how to catch them easily. Now, a good hacker be harder to catch, right? This is not a good hacker. You can see, to begin hunting, we're looking for network connections that originate from suspicious ports. So 4444 and 5555. By default, Metasploit uses 4444. When I'm doing a lot of my CTFs and stuff, I use 4444 because it's already default and I'm not worried about getting caught, right? If I was going to do a regular attack, would I use 4444? That wouldn't make a lot of sense, right? Because if anyone's looking, that's the first place they're going to look if they're looking for Metasploit. So what do? They create a rule here, and I'll show you guys real quick. The configuration files here are in here. Let's go back to desktop. Tools, configurations. you can see these are the configuration files. We'll open one, and you can get these configurations from wherever. These are from GitHub, if it'll load. But we'll open this configuration file, and it'll just show you the configurations that are built. So you can see here's the configurations. It's not a pretty format here. Yeah. Okay, scroll down. There you go. So you can see these are the configurations. Now, these are ones from GitHub, meaning that someone else designed them for you, but you can see that these are the configurations. And the only reason I'm showing you can open these and look. The only reason I'm showing you is because that will make more sense now when you look at this, because that's all this is this is just a rule set that's in that configuration file. So one of the configuration files rules they have here is include, okay, if it's on port 4444 or 5555. So include any network connections on those ports, meaning log that for me, okay? Now you'll see a lot of include, but you'll see a lot more exclude, because rule of thumb is typically you want to exclude things, not include things. That way you don't miss anything, but it just depends on the configuration file. So here we're looking for, it says here you can open the hunting Metasploit event viewer file. This is the exact event that happened that they're having you look for, so there's no real point to. But you can see, if you look, destination port 4444. Now, here you can see that there's a source IP, the host name, that's the port it came from. And you can see it's I mean, this one's a little more obvious, right? It's a shell.exe, like obviously. But if a good hacker wouldn't just be this obvious, but a lot of script kiddies will. And the reason I say that is because a lot of script kiddies go on a site like TryHackMe, see something, and do that exact step into a machine. Now, what you're thinking is, okay, well, that's fine. I don't have to worry about script kiddies. But the problem is they're actually more prevalent, because a good hacker isn't going to waste their time on, you or low-hanging fruit. They're going for bigger targets because they're better. A script kiddie is going for anything it can spray, right? So they're going for clout, that type of thing. So be careful of that, because sometimes these obvious attacks happen more often. All right. So now hunting for open ports with PowerShell. So this is on Event Viewer. We see how to check it, right? We go on Event Viewer on the sysmon log, and we're looking for this 4444, and boom, figured it out, right? This is going to be event ID 3, which is network connection. Now, here is the exact way to do it with PowerShell, which is the same thing we already covered. So get Windows event path. Now, this is a saved file. And then the system event ID is 3. And here you can change the port, and the destination port doesn't matter, but the data is 4444. And you can see you get the same thing. Perfect. Now, let's detect Mimikatz. Now, I'm going through this fast, guys, because a lot of this is reading. A lot of this is stuff you guys can do. The actual investigations are at the end, and that's where we're going to start diving into some of this stuff. So, Mimikatz, if you guys aren't familiar, great tool, used a lot. You can see it's mainly known for dumping LSAS, so it's going to give you a lot of information, but it's kind of loud. Now, here's how you can catch it. Okay, so there's a couple ways. So you can detect the file creation. So if you include the condition and you look for the name Mimikatz, that name probably will never come up organically. It will only come up typically if someone's trying to use Mimikatz, right? Now they might change the name of the tool, but when it creates stuff, when it's running things, the likelihood of that coming up is very high. Okay, so then the other thing is you can look for abnormal LSAS behavior. So LSAS dumps, if you run, you can see here, include lsas.exe. You're looking for those LSAS dumps. Now, when that happens, it's not normal. So if it happens, you might have done it on purpose. That might be something you did, and you'll be able to find that in the log, and that's fine. It's just a couple of logs here and there. But if you notice it and you say, I'm looking at my logs and I didn't do that, I don't know what it is, okay, let's investigate, right? That's the whole point of this. Now, a SIEM will give you an alert on this. That's the whole point of a SIEM. So a SIEM, it will take these logs in and look for specific things and give you an alert and say, whoa, this popped up, look into this, right? Okay, So you can see here, the users downloads mimikatz.exe. That would be easily caught because of both things. You have here, the Mimikatz name pops up. Perfect. You found it, right? So you can see this is the actual, this would be the actual alert, or not alert, I'm sorry, the actual log that pops up. Pretty easy. And in Event Viewer, to view an attack using obfuscated version of Mimikatz to dump. Okay, so they're saying they use an obfuscated version of Mimikatz, meaning you don't see the actual Mimikatz ran, but then you'll see the LSAS dump. So, boom. You can see here, they also say here, exclude the service host.exe. Now, the reason they do that is because if you go through the logs, there's some LSAS dumps that actually the service host.exe is doing, and they're not worried about those because those are natural. Now here, same thing. They're showing you how to use the filter for PowerShell to get the lsas.exe dump. Boom. All right, so let's hunt malware. Okay, hunting malware. Now, this comes in many forms, like it says, with different end goals. Now, the big thing is you're looking for rats and backdoors. The reason for that is because that's what you don't want backdoor connections. That's the key, right? Now, if someone runs malware on a machine and it's doing something, you can shut that machine off or re-image it or whatever. But if they have a backdoor access or a rootkit or something like that, okay, now you're in trouble, because unless you notice it and turn it off or shut it down, when you restart that computer, it's going to come back up, okay? So rats and C2 servers, so remote access Trojans and C2 servers are pretty simple. C2 server is a server that calls back, all the rats call back and say, hey, I want, whatever, I'm waiting for instructions. All right, so let's go ahead and look at it. First technique we're going to use is similar to hunting Metasploit. So we're looking for well-known ports. So if we know a port, certain rats or certain malware, so like when a big malware attack comes out, typically all of them, not all of them, but they get sprayed out to a lot of places, right? When that happens, the software or the malware is all the same. So it's going to start calling back certain ports to the C2 server to try and call back. Now, when that happens, what we can do for ahead of the game is as soon as we figure out what port that malware is using, we can start searching for it using our rules. Once that happens, boom, okay, we got an alert. We've got one computer or one endpoint that is actually, calling back. That's a problem. Let's get rid of it. Okay, so you can see here, when you go ahead and load in, this is a live rat being dropped onto the server. You can see, you can see bigbadrat.exe is where it's at. It's under downloads, obviously. And you can see TryHackMeThreat is the user. All right. You can see there's the source IP and the destination IP. Pretty easy. Pretty self-explanatory. The destination port is 8080, so it is using it over regular HTTPS. All right, and you can see here, this is how to filter it. Again, the filtering is pretty much the same on PowerShell every time. You just change some things. All right, now hunting persistence. This is where you're looking for those connections. And you can see, for instance here, if you know the name of the target file, or let's say the malware has indicators of compromise, meaning specific file names, specific file hashes, that type of thing, you can put those in your rules if you want to. And a lot of SIEMs, if you have third-party SIEMs with third-party database dictionaries, they will update these constantly for you. So keep that in mind. Now, you can see here, they added actually that these are upon startup. So they're looking for persistence, meaning when you restart that computer, does that connection automatically start up? If it does, that's a problem, because it's not very common that you're going to start your computer and all of a sudden you're reaching out to a random IP address, right? And keeping that connection. That doesn't make sense, right? Why would you do that? So you can see here is you can see it says notepad.exe, but you can see the actual file name is persist.exe, okay? So you can see this is what it's pretending to be. This is what it actually is. All right. Hunting registry key persistence. This is a little harder to find, but if you have it done correctly, you can find it. Meaning, they're going to change the actual registry. Now, you can see here, they're using Windows regedit.exe, and they're changing the actual registry. They're changing the software, Microsoft Windows current version run, persistence, and they're adding this malicious.exe to it. So that's a problem. Obviously, malicious.exe running persistently would just keep a backdoor open. You don't want that. Okay. And you guys can read through a lot of this. I'm skimming it, but you guys, I'm just explaining the concepts. You guys can read through and see how to actually create the rules and everything. Now, hunting alternative data streams. We've covered alternative data streams before. Typically, what it is, as you guys know, there's alternative data streams on files, on NTFS, and when this happens, it's usually to, put metadata, that type of stuff, but you can use it to actually add malicious data that's not normally seen. So you can see here, they're saying if it's in downloads, temporary file, any of that stuff, and it ends with a .hta or a .bat, so a .batch file, any of that stuff, we want it out of here. I don't want to see it because if we do, it could be malicious. Now, you can see here, here's the target file name. C users Windows, C users admins downloads, not malicious.exe. So that would be the file. But then in the metadata is malicious1. So, or not in the metadata, in the alternative data stream is malicious1. So if you guys have looked, if you go to directory R, this is a Windows machine, you can see here's the not malicious.txt, but then look, then you have the malicious.1 data or malicious1 data. That's in the alternative data stream. So keep that in mind that is possible, and there are ways to search for alternative data streams that cause issues. Now you can see here, here's one of them. Let's see. Open and viewer to observe a process hollowing attack that abuses the Notepad process. So again, you can see it's located at notepad.exe, but it's actually running PowerShell. It's a problem. As you can see, the above image PowerShell.exe is creating a remote thread accessing notepad.exe. This is obviously okay, and could in theory execute any other kind of executable. So it's a proof of concept. Got it. What they're saying is this is running and it's creating a remote thread accessing this, but it could theoretically access whatever we wanted. They're just showing us Notepad so that there's nothing malicious there. Okay, now again, filtering, exact same thing. We're just changing the event ID to 15 instead of, which is the file stream created, rather than the actual, and ID 8, which is create remote thread. So keep in mind the event IDs are the key because Sysmon's event IDs are different than regular event IDs. Okay, now practical investigations. This is where we start diving into it. So first question, what is the full registry key of the USB device calling service host.exe in investigation 1? So here we go to scenarios, investigations, and luckily there's not a lot of file or logs in here. You'll see. So the scenario here. Bill, that's the wrong USB. In this investigation, your team has received reports that a malicious file was dropped onto a host by a malicious USB. They've pulled the logs, and you're tasked with the figuring it out, basically. Okay, so let's go down here. Why won't it let me scroll down? Okay. So details. So first things first, make this big so we can see it. So you can see the registry is values being set here. Okay. So let's go ahead and look at it. Network connection. Okay. Okay. So here you can see this is where the USB is being accessed. Okay. USB storage. And you can see this is that's the actual path. Okay. But here's the service host.exe. And the question asks, what is the full registry key of the USB device calling service host.exe? So that's this one. It's calling the service host.exe. So this is the full registry. Boom. That is the full registry path right there. And you can tell that because if you go here, well, number one, it says registry value set. Number two, if you go here, this is a registry value set here, but it's accessing that instead of service host.exe. So that's different. Okay, so now what is the device name when being called by raw access read in investigation 1? What is the device name when being called raw access read in investigation 1? Okay, get through there. So, raw access read, you can see that. And what's the device name? And there it is. Device hard disk volume 3. That is it. Okay, so what is the first executable? The process executes in investigation 1. So the first executable, first thing that happens, right? All right, let's look. Boom, boom, boom. I hate that it won't let me scroll down. That's driving me nuts. All right. So the first executable, the process executes. Okay, so that's the first executable, but that's not the first one that the process actually runs. Okay, there's explorer.exe. Let's see if that's the first one, though. What is the first executable? The process executes in investigation 1. Come on. What we got here? That's just boot PC. Okay. So we're looking for the first executable that the process actually executes. Let's go up here. Oh, it drives me nuts. I can't scroll down. And there it is, rundle.exe or rundle32. Now, the way we know that is simple. If we go down here. So you can see this right here is when it's actually being, the process is actually happening. And then the process being created here is explorer.exe. That's it's already been accessed. Here we have and you can see here they're pretending to be the calculator.exe, which is pretty clever, I guess, but they'd get caught. And you can see, where is it? Rundle32.exe. Now, okay, so now we're on investigation 2. So the scenarios change every investigation. So I'm going to read them to you. This is not an HTML file. Another suspicious file has appeared in your logs and has managed to execute code masking itself as an HTML file. Okay. Come on. Hopefully I didn't click that twice. I think I did. Okay, I didn't. Okay. This one, three logs. Okay. So what is the full path of the payload in investigation 2? Okay, full path of the payload in investigation 2. Let's go ahead and go to the first one and see what we've got. All right. So here's the payload. We'll go to details so you guys can see it better because it's. So you can see, here's the actual payload. Okay. Let me make sure that's right. Yeah, that's right. Okay, so that's the actual payload there. And then the payload, you can see here, was the full path of the payload. That's the payload. Was the full path of the file the payload masked itself as. And you can see it's masking itself as this mishta.exe. Okay. So now what is the IP of the adversary in investigation 2? So now we're looking for the IP. Well, here's a network connection. So that's going to be where our IP is. And you can see, if we go here, IP is 10.02.18 right there. And then what back connect port is used? 4443. Boom. Easy day. This one had 3 logs. That one's pretty easy to figure out. Now, investigation 3.1. All right, first question. Well, scenario changed. So your team has informed you that the adversary has managed to set up persistence on your endpoints. Okay, so find out how they managed to gain persistence. Okay, so now we're looking at what is the IP of the suspected adversary in investigation 3.1. So let's look for the first network connection. Here it is. And 172.30.1.253 right there is your destination IP. So that would tell me that is the IP of the suspected adversary. What is the host name of the affected endpoint? So what's the host name of whatever is being affected? And right there, desktop 0153T4R. That is our host name. All right. What is the host name of the C2 server connecting? Okay, so this one you guys may not know because you may not have used C2 servers very much, but Empire is the name of it right here. Empire, it literally says Empire C2. So if you put Empire C2, that's the host name of the C2 server. There you go. Now, where in the registry was the payload stored in Investigation 3.1? So again, we're looking for registry. And you can see, all right, so you can see here it's asking where in the registry was the payload stored. So here, registry value was edited. And you can see this is obfuscated, obviously. But here, HKLM, software, Microsoft Network, debug. That is where it was actually stored. It was actually put in the debug part of the registry. Okay. So now, what PowerShell launch code was used to launch the payload in Investigation 3.1? So we need to find the PowerShell. So we know these are all registry edits. So these aren't going to... Oh, there's one. All right, so here it is. PowerShell, and then here... See, it wants the whole thing. Okay. So it wants the whole thing. So this whole launch code here. Boom. So that is what PowerShell launch code was used to launch in payloads. So there it is. And the way I knew that is because we already saw this registry value. So we had to go to the next one and see what they were doing. All right. Now, was the IP of the adversary in 3.2? And this is the same investigation, so there's no scenario change here. All right, investigation 3.2. And what is the IP of the adversary in investigation 3.2? We'll go back to here. All right, and there it is, 172.168.103.188. Boom. And again, the way to figure that out is I'm just going to the first log. That's a network connection, and there you go. Now, what is the full path of the payload location in Investigation 3.2? The full path of the payload location. All right. Payload location. All right, and the full path. Let's see. This isn't the full path. So we're looking at the process created, and no, that's close. There we go. So see Windows, System 32, scheduled tasks, create, blah, 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 this whole thing. And you can see here, that's this whole thing. Create FSC daily. So they're creating a scheduled task, and that's going to be where the payload sits. Now, what process was accessed by scheduled task.exe that would be considered suspicious? Well, let's take a look. Do we see it there? This is just putting it there, so it's probably going to be after that. Okay, it says my machine terminated, so let's hope not, because I actually extended it, but hopefully it didn't. I'm going to be a little upset if it did. All right, I'm looking for some. These are network connections. I don't know why I'm looking at those. All right, what's the question? What process was accessed by scheduled task.exe that would be considered suspicious? Okay. You can see this is a whole thing. All right. Where are you at here? It's hard to read with that, how blurry that is. I need to just keep it on the details page. Okay, so there we go. All right. That's the scheduled tasks. There it is. Okay. I knew it'd be right after that. I couldn't figure it out. Okay, so there it is. The lsas.exe. And that is the process that was accessed. Now, if you remember, LSASS tells us it's probably Mimikatz. So now what is the IP of the adversary in investigation 4? Let's see if we can just click here if it saved it. Oh, it did. Perfect. Okay, so again, scroll down to the bottom, get the first network connection, and the IP of the adversary, 172.301.253. Now, what port is the adversary operating on? Port 80. And then what C2 is the adversary utilizing? If you remember what we said, Empire. That's what they're utilizing. So there's your answers. 172.30.1253, port 80, Empire. Now, I will slowly scroll through these since there's a lot of answers, and I kind of went fast so that way you guys can see them. And hopefully you guys can get the ones you need, pause it, whatever you got to do. All right, there you go. Now, hopefully you guys, this made sense. This is all about just investigating, finding what happened, trying to figure out the source of what is going on using Sysmon. Now, Sysmon is different than your event viewer. You can open it in event viewer, but Sysmon lets you really actually filter out and add rules that you can control that will really control what logs you're looking at. And keep in mind, they have totally different event IDs than Windows Event Viewer. So make sure you understand the difference. And remember that Sysmon, almost every application, machine, everything, will typically say, if it's a big name, will say we have Sysmon logs that you can import into your SIEM. So hopefully you guys, that makes sense, because once you import everything, you can start pulling in all kinds of freaking logs, and you can actually access them in a very nice GUI format. So hopefully that makes sense to you guys. Hopefully this helped you guys. And if you guys enjoyed it, please hit that like and subscribe button. It helps out a ton. And we are going to finish this cyber defense path, even if they won't finish it for us. Thanks, guys.